Okay.
Yes, thank you.
So as I said, so here so I try to gather some information about this process of urban heat island and its interaction or interplay. Yes. So this interplay between the urban heat island and the heat wave. So this is one of an example of the compound. You remember I told you in the previous presentations that future climate will bring more and more often this compound extreme event, where you have, for example, heat waves and drought. So now we are starting to work on this compound. What is the impact of this compound on cities? Because on cities, you will not have only drought and heat waves, but you will have also urban heat island. Okay, that should be taken into account also during this, if you have a compound. But here I just, we will just cross some result that has been published all over the world of this interaction between the urban heat island and the heat waves. So yes, so this I already explained you last time, that you have the urbanization and you have the global warming, and the interplay is how this urbanization can interplay with the global warming. So you have the urban heat island, and it can interact with the heat waves, for example. How this impact interact, and is there a positive or negative, but I already explained you this. So the first example that I will give you is the one that I study for Brussels, so where I live. And here, as I told you, so we have observation and we have model. And then we wanted to know, during the heat waves, if the urban heat island gets bigger or less during the heat waves. Because this is very important. As I told you, the urban heat island during summer is good. We don't care, so it's nice. But our problem is that when you have heat waves, because then the urban heat island, you can have a lot of impact on mortality, morbidity, admission to hospital. So how the urban heat island interplay with the heat wave, and we found that it intensified. You will see. So this is Paris. If you look here to the bottom, so this is a paper that I published quite a long time. So here this is Brussels, okay, and this is the center, and this is during the night. So this is a model, our model that we run over the city. And you see that the urban heat island during the night, this is night, is about 1.6 degree if you compare to the surrounding. So here we have forest. And during the day is less. So you remember the urban heat island during the night is much more higher than during the day in ours. And this is what I asked you last in the tutorial session to do is to this is for Brussels is per month. You see that how we have the urban heat island every month. Okay, because it's not dependent on the season, it's dependent on the weather type. So if you have an anticyclonic situation, it can also occur during the winter. So you can have also urban heat island. But so this is how it evolved during the month. Okay, during the night and during the day. So we wanted to know during the heat waves. So we are lucky because we have observation inside the city and outside the city. And so here you see so this is a mean over 30 years. So this has been published in 2016. And this is from the observation, okay? So the value of what we call the background urban heat island, okay? The background, the blue value. And then here what I put in red is when we have a heat waves. So when a heat waves occur on Brussels, you can see that what we found is that when we have a heat wave, you see that the urban heat island get intensified. So this difference between the city and the urban is not the same, because you can say, okay, even if it's a heat wave, this difference should be the same. But in fact, no. There is a synergetic interaction between urban heat wave and urban heat island in the sense that if you have a heat wave, this heat wave will affect a lot will affect, not a lot, will affect differently the city and the rural area. And I will explain you this why. So this is from our model. You can see that the simulation, we can reproduce this, but the extreme are not that extreme. So the model is still cannot reproduce how the urban heat island intensify. So when you use model, you should be careful that maybe, this is known, that model are not very good in reproducing the extremes. So you should be very careful when you use model that, maybe your extreme in the model is not that extreme. Yes, so before going to this, I will explain you why. And the reason why the urban heat island during heat wave get intensified, because during heat wave, we found that the sensible heat flux will be higher in the city because you have heat waves, so you have more heat. So this heat, this energy, extra energy during the heat waves will be used as sensible heat flux. You remember the sensible? So you will have a more exchange of heat. So it will increase the sensible, more temperature, but for the rural area, the heat waves will not increase the sensible, but it will increase the latent. Because you have more, all this extra energy will be used by the soil to evaporate. This is if you have a lot of water. So if you have excess of water, this is our case, is that you see the heat waves impact the city differently from the rural, because in the rural is the latent. So this extra energy is used to evaporate more. So if you evaporate more, the rural area gets cool more. So that's why the difference will get like this. So it's intensifying, okay? So this is what we found in Brussels. And then I found this yesterday, this paper by Lei Zhao, so he's working in USA. And what he did, so he investigates this intensification for USA, so you're here, and for different background climate, because for my city is temperate. So Brussels is temperate climate, okay? And then he investigates, and his team, they investigate the intensification for all these cities here. So you have temperate in blue, like Brussels, and you have also dry, okay, here, and you have also continental city, this green city. So he used a model, climate model, to investigate the interaction between the urban heat island and heat wave in these 50 cities in the United States under current and future warming. Because what I show you, it's only under what I did for Brussels was only during the present climate. So he investigate also, but he used climate model. So we should be careful when we use climate to reproduce this interaction. Sometimes the process are not well parameterized in the model. But we will see what he found, what they found. So if you look here to the D time, they found that the difference in the increased urban, so here, let's look here. So they found, for example, here you have the D time, okay, and you have the night time. So this is during the day, and this is during the night, and this is the current climate, and this is the future climate with this scenario, okay? It's a middle scenario. And this is in the far future, but with the high emission scenario. So the business as usual. So, and this is the day and this is the night. So what has been found is that the difference in the increase of urban versus rural evaporation and enhanced anthropogenic heat emission, air conditioning, during heat wave are key contributions to the synergetic effect during D-time. So they found that there is a synergetic effect during D-time. So the urban heat island get intensified during D-time, and this intensification is due to the enhanced anthropogenic heat emission in the urban, and then the enhanced evaporation in the rural area. So this is the same, like the process that we found in Brussels. And at night, the enhanced release of stored and anthropogenic heat during heat wave are the primary contribution of the synergetic effect. So they found also that there is an intensification of the urban heat island, and it's more or less the same process that I explained you for Brussels. But, so yes, but what I wanted to tell you here, but I think it's for the dry, but because he did this for, yes, for dry and for temperate. So what we found here is that if you look, for example, let's look to the dry, okay? The dry cities, so it's the blue, so this color, so the blue and the red. And let's compare, for example, during the night time here, for example, the night time, and let's compare between the current and then the future climate, okay? You see that what they found here, it's, let's look, for example, this is during the day. Yes, during the day, the day, I think, yes. So in fact, you see that there is an increase, you see, between the current climate and the future climate. It's a big intensification. So they found that for the dry climate, this intensification will get bigger. They found that for the dry cities, in the present climate, there is not a big difference between heat wave and non-heat waves. But in the future climate, you see here, the difference between this and this. In the future climate, these dry cities, the impact of heat waves will intensify much more the urban heat island in dry. So there is an impact in temperate climate cities, but the impact is much more higher in the dry cities in USA. So let's investigate also in Beijing. So this is, but as I told you, this has been done by a model. So in the model, you really, as I told you, should be careful because maybe some processes are not well represented for this interplay. So what they found here, what they try to discuss this or to investigate this in Beijing using observation, okay? So they have two towers. You have one in the city here, you see that is urban in Beijing, and then another one in this Xi'an. So it's here, it's more rural station, okay? And so this is observation, right? Okay, so there is no model. And so this study analyzed observation from two flux towers. So you have the temperature, but you have also the flux, because then we can investigate if this impact of surface fluxes are really good, because we have the observation. They have the observation on surface fluxes. This is very important. So if you have this tower, flux tower, you can get this observation. And this reveals significant difference between the response of urban and rural, and here it was cropland ecosystem to heat waves. So they found also that the heat waves impact differently the city and the rural area. So let's look to this graph. This is the difference of temperature at 8 meter, okay, 8 meter, and this is the difference at 30 meters, so a little bit higher, but it's more or less the same. So let's focus here on the 8 meter. So the blue is the urban heat island during the background. So it's a background situation. You see that, and this is the time. You see that this difference, we don't retrieve this curve like this that I show you. So it's more flat. You can see that the urban heat island in Beijing is a little bit, seems to be flat. So taking these two stations. But what they found is that during the heat wave, so it's the red. Okay, during the heat wave, the urban heat island get intensified. So during the night, a little bit during the day, but mainly during the night, the urban heat island was intensified. So it's also intensification. And since they have all the radiation and energy balance, they could investigate why this. So they say that the urban site receives more incoming shortwave radiation and long-wave radiation due to the heat wave as compared to the rural site. And this results in a larger radiative energy input to the urban surface energy balance. What they found? They found that during the heat waves, the urban receive more solar energy than the rural area. So you have more solar energy. Why? Maybe because in the background, you have more aerosols. So if you have aerosols and you have activity, so the solar radiation will decrease. But during the heat wave, it seems that you have more solar energy that can reach the urban area more than the rural area. And so this is what you can see here. So during the heat wave, you have more in the urban than in the background. And then they check also now the energy balance. They found that the change in the turbulence heat flux also diverges strongly for the urban and the rural side. The latent flux increase more significantly at the rural site due to abundance of water, available water, while sensible heat flux and possibly heat storage increase at the urban site. So we can check this here. You can see that for the H, it's more the urban here. You have more urban, more sensible in during the heat wave. And then for the latent, you have more evaporation in the rural site. Okay, so it's confirmed more or less what we found in Brussels and in the temperate is that you have, during heat wave, you have difference. Heat wave impact sensible heat in urban, and it impact latent heat in rural area. And this intensify, okay? So let's look now to a literature study. So this study, it's a review study, so it's not only in one site, but it's different, so they look to different papers in the literature, and this is all the number of papers that they found. So this is article per country, so we can check here for India. So I think that here it was between 1 and 2 papers that study Indian cities and how they, but again you can see that, for example, for the Africa, it's less. We don't have a lot of papers coming out from Africa on. So it's always America, Europe, China, and here India. So and Australia. So it's for the next IPCC report. It will be really challenging for us to get information from Africa, because we need some more information from this country. Okay. So they found also. So this is general what they found. So this is what they found here. Is that the urban, during heat wave, so the urban heat island get intensified. So they found that from different papers that they analyzed, they found that the urban heat island get intensified. And why? So there is an increase in long wave radiation due to pollution. Okay. They found also that the excess sensible heat released by building material, like I just showed you, that the heat waves increase the sensible. They found that you have a decreased turbulent transfer. Why? Because you have less wind. When you have heat waves, the wind is less. So if you have less wind, you have less mixing. So if you have less mixing, it's more hot. Okay, so you cannot mix with the air. And then also increased anthropogenic heat emission. Why? Because during heat waves, a lot of people use air conditioning. Okay, if you use air conditioning, you have more anthropogenic heat which go to the which is released. So it will warm. We did this exercise for Paris, and they found that the air conditioning that is used in Paris, it can increase the outside temperature by 1 degree. So during heat waves, if you use anthropogenic heat, you will just exacerbate the temperature, it will be more. And also decreased evaporation loss. Why? Because this is in urban, not in rural. So you have a decrease because already you don't have evaporation in cities. Okay, so it will still decrease this. And voila. So this is more or less all the process that has been found. And they found that the amplification of urban heat island during heat wave period caused a rise in ambient temperature up to 5 degrees. So they found an increase in temperature. Now, I checked also in the literature, but there is other papers that found that it's not an increase. They found, in fact, a decrease or the same. And this was in this tropical city, Singapore. So, and here it's by observation. So you have an observation here. Here, this is the city, this station. And then you have an observation here. It's rural. It's considered as rural. So you can see the difference. This is the urban. Should be somewhere here. And then the rural area. But you see that we have also the impact of the ocean. So tropical climate. So they did not found any difference in the urban heat island during heat wave and non-heat wave. You can see that this is the pre, it means before the heat waves. HW is during the heat wave, and post is after the heat wave. You can see that the three curves are more or less the same. So they did not find any difference between urban heat island with or without heat wave. So yeah, but it's tropical. I think that is tropical climate. So it has not been investigated, and it's also, I think, related to some ocean impact for this city. Okay, now let's focus on India. And I found a recent paper by Kuma and Mishra, but this is surface urban heat island. So it's not air temperature, okay? It's the surface. It's the surface urban heat island and how it evolved during heat wave. What they found, so this is, so this is using satellite, right? Using satellite data. And so they make this study over Europe, Asia, North America, and Australia. Let's focus, for example, in Europe. So the point here which are red means increase, intensification of the surface urban heat island. So the surface urban heat island get intensified. during the heat wave, which is consistent with what we found in Brussels here, and also which is consistent what has been found for the temperate cities in Europe and then also in US. But let's focus on India here, for example. So they found that in majority of all the cities, you have summer, but majority is blue. It means that in India, for example, they found that the surface urban heat island did not intensify during the heat waves. And so this is what they put. Surface urban heat islands surrounding non-urban area are warmer than, so the surrounding non-urban area are warmer than the urban area, okay, during heat wave. Why? So here in India, they found that the surrounding of cities is hotter, get warmer than the city itself during the heat waves. And this is due to absence of vegetation. So they found that when you have heat waves, this is maybe due to the monsoon, you don't have vegetation around, and the fact that you don't have vegetation, this will not impact, so the rural area get warmer than the city. And you have maybe also irrigation, some irrigation in the city, so which make this, this difference. So you see, in India, it's more or less cooling of the surface urban heat island during the heat wave. But I did not find, for the air temperature, I did not find papers. So this is only the surface urban heat island, okay? And voila, so that's it. Thank you very much.